Okay, here we're going to do, before I even attempt to expect anything out of any of you as far as finding area using this process of summation, the limiting process of summation, we need to get some more practice here. Okay, so remember, what we need to do is first find the width, which is the upper end point minus the lower end point over n, and then the height starts at the lower end point plus the width times I. Okay, so we're going to use that and find the area under the curve of x squared plus 1 between 0 and 3. Okay, so the first thing that we're going to do is find the width. So I'm just going to do some erasing here. And the width is 3 minus 0 over n, which is 3 over n. Now, the lower end point, our a value there is 0. So the height would be 0 plus the width times I. Okay? So our height is going to be the width of 3 over n, and then we're going to put the I there with the 3. So the height of that curve, or the height of each rectangle, okay, where it meets the curve, is 3I over n. All right, so our summation, our area, is the limit as n approaches infinity of the summation from I equals 1 to n of x squared plus 1. That is our formula, okay? Now, what I'm going to do is I'm going to replace the x squared with the height, okay? So our height is 3I over n squared plus 1. That's our height, and then we need to multiply in the width. Okay, so that sets up our summation to find the area. Okay, so, and yes, you need to write the limit as n approaches infinity, okay, of the sum from 1 to n of 9I squared over n squared plus 1 times the width of 3 over n. Now we're going to be able to distribute, okay, the sum from 1 to n of, now we're distributing the 3 over n to get 27I squared over n cubed plus 3 over n. Now we will separate the terms and take the sum of each one. So the limit as n approaches infinity of the sum from 1 to n of 27I squared over n cubed plus the limit as n approaches infinity of the sum from 1 to n of 3 over n. Okay? Now the next thing is to pull out any numbers along with any powers of n. Okay? So, and we're going to put those out in front of the summation symbol. So 27 over n cubed, because what we want here is to isolate any I terms. So we'll do the same thing with the second term. The limit as n approaches infinity of 3 over n times the sum, and when we factor that 3 over n out, we're left with a 1. Okay? Now at this point, we're going to replace the i's with our formulas in terms of n for the summation. So the limit as n approaches infinity of 27 over n cubed, and in terms of n, I squared is 2n cubed plus 3n squared plus n all over 6. And then again, plus, and we're just going to write that limit once because now we're the limit of the whole entire thing, 3 over n. And the constant summation is going to be times 1n, which is just times n. Okay? Now, the next thing we're going to do is distribute the 27 over n cubed into each one of the terms in the set of parentheses. So 27 times 2n cubed over 6n cubed. So 27 times 2, and we're going to have to go back up here. We have the limit as n approaches infinity of 54n cubed over 6n cubed, and then distributing the 27 over n cubed into 3n squared over 6. We have 81 n squared over 6n cubed, and then that last distribution is 27n over 6n cubed, and then 3n over n is just 3. Okay, so we've gotten to the point now where we can look at canceling out some of our n's. These are equal power, so the limit as n approaches infinity of 54 over 6, okay? Now, even if we took these n squareds away, leaving 1 in the denominator, 81 divided by infinity is 0. Likewise, 27 divided by infinity is 0. Okay, that's why when n approaches infinity, we are allowed to cancel out those terms because they are zeroed. Now, 54 divided by 6 is 9, and 9 plus 3 is 12. So the area under the curve x squared plus 1 from 0 to 3 is 12 square units. Okay? More practice. Now we're looking for the area under the curve of 1 minus x squared between the a value of -1 and the b value of +1. Okay, so the width is b minus a. So 1 minus a -1 is 1 plus 1 over n, which is 2n. Now here, we need to pay attention because remember, the height starts at the lower a value of our endpoints. So the height is -1 plus 2i over n. So it's the width of 2 over n times I. Now, for as far as the summation goes, it's the limit as n approaches infinity of 1 minus, and we're going to replace the x with our height, squared, okay? And then we're going to multiply in the width. Okay, so we're all set up. Now, algebraically, we are going to FOIL out -1 plus 2i over n times itself twice. And what we get when we do that is 1 minus 4i over n plus 4i squared over n squared, and then we'll multiply in the 2 over n, which is our width. So we are still algebraing here to get 1 minus 1 plus 4i over n minus 4i squared over n squared times the width of 2 over n. Still simplifying, 1 minus 1 is gone. Okay, so these two things subtract each other away, and we're left with 4i over n minus 4i squared over n squared times the width. Now we will distribute in, and I've left off the summation from 1 to n. We will distribute in the 2 over n. So I say don't leave it out, and I left it out. All right, so distributing in the 2 over n, we get 8i over n squared minus 8i squared over n cubed. Okay, not too bad. Now we'll split up that summation. And so we'll get from 1 to n of 8i over n squared minus the limit as n approaches infinity times the sum from 1 to n of 8i squared over n cubed. Next step is to pull out a constant and any n that we've got. So the limit as n approaches infinity of 8 over n squared times the sum from 1 to n of I minus the limit as n approaches infinity of 8 over n cubed times the sum from 1 to n of I squared. So now that we have successfully isolated our I and our I squared, we can make the replacements for I in terms of n. All right, so we're going to be in the second column. Okay, so the limit as n approaches infinity of the sum from, dropping your summation symbol because we're replacing n, or replacing I with n squared plus n over 2, okay, minus, and we'll just take the limit of that whole thing, 8 over n cubed times the equivalent of I squared, 2n cubed plus 3n squared plus n all over 6. Okay, now comes the distribution. Okay, we're going to have 8n squared over 2n cubed plus 8n over 2n cubed minus 16n cubed over 6n cubed minus 24n squared over 6n cubed minus 8n over 6n cubed. Okay, now we can cross out all of the values that will go to 0, which is this one, the n cubes cancel out, and we are looking at negative 6 over 6. And that's it. Okay, just found my mistake here. That's supposed to be a squared. So everything, I'm going to just redo this, okay, because we should not end up with a negative area, which was why I paused and reconsidered what I wrote. Okay, so now we'll distribute, because that was an 8 over n squared, and I had right here 8 over n cubed, even though over in the left-hand column I had written n squared. So revisiting, we'll have the limit as n approaches infinity of 8n squared over 2n squared, there we go, plus 8n over 2n squared minus 16n cubed over 6n cubed minus 24n squared over 6n cubed minus 8n over 6n cubed. Okay, so again, any of these values that we know we're going to end up with an n in the denominator when we reduce everything else away is just going to go to 0, which is all three of those. Okay, so as n approaches infinity, 8 divided by infinity is 0. Okay, so what we're left with is the n squares cancel and we get 4. 8 over 2 is equal to 4 minus 16 over 6 is the same thing as 8 over 3 because those n cubes cancel, leaving us with the negative 16 over 6. Now that area is 4 minus 8 over 3 gives us an area of 1 and 1/3. Okay, so that's the area when you use your summation. Then we've got yet another one with more than one x. Okay, so we'll start with the width. It's equal to 1 minus 0 over n, which is just 1 over n. And our height is the lower end point, which is 0, plus the width times I. So 1 times I is I over n. Okay, now we'll fill in the limit as n approaches infinity, the sum from 1 to n of, here we go, 2 times I over n minus I over n squared times the width of 1 over n. Okay, so we can do the multiplication now. We have from 1 to n of 2i over n minus I squared over n squared times 1 over n. Very, very simple algebra. And then continuing, we will distribute now the width into each one of those approximations of the height. So 2i over n times 1 over n is 2i over n squared minus I squared over n cubed. Looks much more difficult than that, but there you have it, not that big of a deal. Okay, now we're going to separate the terms. So the sum from 1 to n of 2i over n squared minus the limit as n approaches infinity times the sum from 1 to n of I squared over n cubed. Pull out any constants over your n terms, so 2 over n squared times the sum from 1 to n of I, and that's what we're looking for. Okay, we want that I. Whatever power on the I is what we are isolating intentionally. Okay, so we've got I and I squared. So once we write the replacement for I in terms of n, we get to drop the summation symbol. So I is n squared plus n over 2, and I squared is 2n cubed plus 3n squared plus n over 6. Okay, now we'll do our distribution and get 2n squared over 2n squared plus 2n over 2n squared minus 2n cubed over 6n minus 3n squared over 6n minus n over 6n. Okay, so all of the terms that end up with only an n in the denominator because the numerator has canceled, all of these, that one will go to 0. This one, and those n's cancel, and those n's squared cancel. So our area is 2 over 2 minus 1/6. Okay, so that's 1 minus 1/6, which gives us an area of 5/6. Okay, and there you have it. All right, so that's just a little bit of an extra practice with summation. Now you're actually going to do some of the problems on your own. Okay, see you guys.